Let's take a look at now at the idea of Rose curves. Rose curves are kind of cool. Now, a Rose curve has the form r equals cosine of n theta. And also very commonly we write this as r of theta equals cosine n theta using typical function type notation. Okay, now for n equals 1, what we have is r of theta equals cosine of theta. And we already looked at that. That's just a circle that essentially goes like this. Now what starts to happen is I change this value of n. Right now it's at 1. When I make it 2, then cool things start to happen. 3, 4, 5, whatever. And what I end up getting is essentially petals rather than just simply one circle. So let's take a look at n equals 2. So now I have r of 2 theta. Well, for r of 2 theta, when theta is 0, 2 times 0 is still 0, so cosine is obviously still 1. Now when theta is pi over 6, 2 times theta cancels and I get pi over 3. Cosine of pi over 3 is, of course, a half. At pi over 4, see 2 times pi over 4, it cancels, that's pi over 2, I'll get a 0. At pi over 3, I have 2 times pi over 3, which is, again, a half. Actually, it's a negative 1/2 because I'm in the second quadrant now. At pi over 2, 2 times pi over 2 is pi, so that's a negative 1. At 2 pi over 3, I'll have 2 times 2 pi over 3, that's 4 pi over 3. And cosine of 4 pi over 3 is negative 1/2. At 3 pi over 4, I have 2 times 3 pi over 4, which is 3 pi over 2. Cosine is still 0. At 5 pi over 6, I have 2 times 5 over pi over 6. Obviously, 2 is going to cancel and give me 5 pi over 3. And at 5 pi over 3, cosine is a half. And at pi, I really have 2 pi, so cosine is 1. Now, I will probably need to take this out a little bit further, but let's go ahead and go that far and see what we get. Now, just to help us find these a little bit better, I'm going to pick a different color here. No, I'll stay in black. This right here is roughly pi over 6. Over here, we're going to have roughly pi over 3. Over here, that's going to be roughly 2 pi over 3. And this is going to be approximately 5 pi over 6. And then we can keep going with this as we need to, and we will shortly here. But let's just take it from 0 to pi right now. From 0 to pi, when theta is 0, radius is 1, so I'm going to be out here at 1. When theta is pi over 6, the radius is a half. So here's my half ring. I'm going to come up and right there, it's approximately a half. At pi over 4, this angle, I'm going to be at 0. At pi over 3, here, this angle, I'm going to be at negative 1/2, which means I'm going in the opposite direction. I should probably go ahead and draw this in a little bit, because the opposite direction is going to be roughly here. So I'm going to be at negative 1/2, which is going to be, here's my 1/2 mark, roughly here. So let's see what's going on. It looks like I'm going here to here. And then where am I? Pi over 3. Next is pi over 2. At pi over 2, I'm at negative 1, so I'm all the way down here at negative 1. At pi over, where's next? 2 pi over 3, I'm at this angle. At 2 pi over 3, I'm at negative 1/2. Well, here's a negative 1/2. And let's go ahead and draw in, where am I here? Right about here. And I said negative a half, so here's the half ring right there. So I'm coming around here. At 3 pi over 4, this angle, I'm at 0, so I'm coming back up to 0. At 5 pi over 6, this angle, I'm at a half, so here's my half ring, followed all the way around to 5 pi over 6, so I'm right about there. And at pi, I'm actually at 2 pi, so it's 1, so I'm out here. So I think you can see what's going on. Basically, I have half of this drawn now. If I keep going to 7 pi over 6, let me get that angle drawn in. This is approximately 7 pi over 6. 5 pi over 4, and this is going to be 4 pi over 3. 3 pi over 2, then 5 pi over 3. And then my last one over here, that kind of missed. There we go. That's going to be 11 pi over 6. So at 7 pi over 6, I'm going to be at a half. So let me see, right there is the half ring. There we go. And then at 5 pi over 4, I'm going to be at 0. So see, I'm coming right back to 0. And then let's see what's next. At 4 pi over 3 at this angle, I'm actually going to be at negative 1/2, which would bring me up here. So see, I'm coming back up. And then you guess it, at 3 pi over 2, I'm going to actually be at negative 1. At this angle, radius is negative 1. So let's go bring it back here. And then I think you can probably see it's going to come back around here and here. So there's my rose curve. For n equals 2, I have 1, 2, 3, 4 petals. Okay, so what happens when n equals 3? Okay, for n equals 3, r3 theta, when theta is 0, it's still cosine of 0, so I would get 1. This is going to be 3 times pi over 6, so that's pi over 2, which is 0. This will be 3 times pi over 4, which is negative root 2 over 2, which is about negative 0.70. At pi over 3, I'm going to have 2 times pi over 3, which is, 3 times pi over 3, which is obviously this is pi, so that's negative 1. Here I'll have 3 times pi over 2, so that is going to be cosine of 3 pi over 2, which is, of course, 0. And here I'm going to have 3 times 2 pi over 3, which obviously is just 2 pi, which is 1. At 3 pi over 4, I'm going to have 3 times 3 pi over 4. That's the same thing as 9 pi over 4, which is going to be root 2 over 2, which is approximately a positive 0.70. And at 5 pi over 6, I'm going to have 3 times 5 pi over 6, which is 5 pi over 2, which is going to give me 0. And of course, 3 pi would be a negative 1. So let's draw these in again. Here's my pi over 6, roughly pi over 3, 2 pi over 3, 5 pi over 6, and we just went out to pi. So let's start putting the values. At 0, I'm at 1. At pi over 6, I'm at 0, so I'm here. So I come up like that. At pi over 4, this angle, I'm at negative 0.7. So negative 0.7, this is 0.7 here. So if I come around there, this ring right there, looks like I'm going to be here. And then at pi over 3, which is this angle right here, I'm at negative 1. So pi over 3, negative 1 is going to be like right here. At pi over 2, this angle, I'm at 0. So I've come back up to here. And let's see, where am I now? At 2 pi over 3, which is this angle here, I'm at 1. So I've come back out and I'm right here. At 3 pi over 4, this angle, I'm at 0.7. Well, here's the 0.7 ring. I'm just going to swing it around, and it should be right there. At 5 pi over 6, this angle, I'm at 0, so I've come back to 0. And at 3 pi, see, 1 pi, 2 pi, 3 pi, this angle, I'm at -1, so I've come all the way back to here. So that's what it looks like for n equals 3. For n equals 3, I have 3 petals. So now let's jump to maple and play for a little bit. What do you expect to happen with 4 petals? Well, let's go ahead and type in the functions real quick. I'm going to have polar plot. And the function is going to be cosine. Let's do cosine of 2 pi real quickly here. I'm sorry, twice theta. And let theta equals 0 to 2 pi. See, that's that Rolle's curve we did earlier. And I'm going to increase the thickness a little bit. And maybe even make it bigger so that's really easy to see. Yeah, that should do the trick. Okay, so that's what we had when n equals 2. So what happens when n equals 3? There's the one that we just drew a moment ago. So now what happens when n equals 4? Okay, n equals 4, I've got 1, 2, 3, 4, 5, 6, 7, 8. I have 8 petals. When n equals 2, I had 4 petals. N equals 4, I've got 8 petals. When n equals 3, I had 3 petals. So let's go to n equals 5. And you expect it to have 1, 2, 3, 4, 5 petals. And of course, at 6, you'd expect it to have, oops, 6, not 56. You'd expect it to have 12 petals. And if you count those, you do. There are, in fact, 12 petals there.